For exercise 1, we're going to let f of x be negative x squared plus 4x and let g of x equal x. On the interval from 0 to 3, consider a Riemann sum with 3 subintervals and right endpoints. It's a sketch on the leftmost graph, the rectangles corresponding to the Riemann sum for f. So since we're only looking at the graph from 0 to 3, right, we're going to break this up into 3 rectangles, and right endpoints mean go to the right edge of the rectangle, draw up to the graph, and then go left to complete the rectangle. So the first rectangle is this area here. For the second one, we're going to go to the right edge, up to the function and over. And then for the third one, we're going to go up to the function and over. So these would be our 3 rectangles for our first function, f of x. This is the graph of g of x, and we're going to use right endpoints here. So I'm going to go to the right and over, up to the function and over, up to the function and over. On the third graph, we want to do the area between the 2 curves using right endpoints. So what we do now is, because I only want the area between these 2 curves, is I go over to the right, I go to the bottom curve, that's where I start my rectangle, up to the top curve, and then over. So my first rectangle looks like this. Same thing here, I'm going to start on the right, go up to my graph, complete it, and this is the bottom. And then for the third one, when I go up to the function, there's actually nothing there. I'm already over. This guy has a height of 0. There's nothing left. Now if I compare the previous 2 graphs, this should make complete sense. So this rectangle had a height of 3, and I subtracted off the bottom square, and so I only got these 2 remaining squares. That would have been the overlap if I had overlaid these 2 graphs. Here my rectangle had a height of 4, and I subtracted off the bottom 2, and so I only ended up with 2 left. Here I had 3, a height of 3, and a height of 3. So when you subtract them off, there's nothing left. So now we want to set up the definite integral representing the total area between f of x and g of x. So we can see from this picture that f of x is on top of g of x. So we read the functions from the top down. So this is the larger one, this is the smaller one. So now we would say, well, the integral from 0 to 3 of f of x minus g of x dx. We actually have the equations for f of x and g of x, so that's negative x squared minus 4x minus x dx. And then I can simplify that even further, because negative 4x minus x is negative 5x. So because we did top minus bottom, this is going to give me the total area of the curve.